Okay, now we'll be talking about the last part, which is the converging and diverging lens. At the same time, we will also be discussing how it will actually affect the bending of light. In exam, you might be required to actually draw one of the 6 combination and explain the properties of the converging lens. So a lens is generally a transparent material that is able to bend or refract light rays as a form to form an image. And this is based on the reflected light rays when they pass through it. So a converging lens is one that converge the light rays after passing through it, meaning right, it will actually all move into the same principal focal point. Okay, and for the principal axis is actually located over here. This is what we call the principal axis, where it's a straight line that passes through the center of the lens at the right angle of the plane. So it's this is the one in red. The principal focal is this point over here that they meet in the middle in order to actually or where the point on the principal axis in which all the incident ray will travel parallel to the principal axis and converge or diverge after the refraction. The focal length is the distance between the center of the length and the principal focus, which is this piece over here. Okay, so in order for the focal length to take place, it will be the distance from here all the way to the principal focus. That's highlighted in blue. A diverging lens is whereby the inner side is thinner than the edge. So you can see that this is actually thinner in terms of distance here as compared to the other edge, which is here, which is bigger in size. And this will actually diverge, which means that the light ray will actually move further away from each other after passing through it. So one way to actually remember how to go about drawing the ray diagram of a thin converging lens is number 1, first determine the height of the object, and at the same time label the principal axis, which will align with the center of the lens. Next, you have to take note of where is the focal point or the focal, so there'll be F here, sometimes it can be until 2F and vice versa. Next, based on the object, right, you take a ruler and make sure that these 2 points are aligned, where the middle of the center of the lens as well as the top of the object, and then you pull and you draw one straight line all the way downwards, and then you draw the arrow. Okay, so this is the first ray you draw. The second ray you draw is whereby the tip of the object pull all the way to the lens, and it should be parallel to the principal axis. Okay, parallel to the principal axis. And subsequently, what you do next is you make sure that the lens, right, from this point, you take a ruler from this point and you mark the other point, which is your first focal length, and you draw it down, and you join it down. There will be a point in which, right, your length, this particular ray, light ray, will intersect the other light ray, and that's where that you will come across this point, and this will then be the top of the head of the image, and therefore you draw either the arrow downwards or upwards to indicate where the image is. So this is how you go about drawing the ray diagram of a thin converging lens. So something like this, based on this image. First step, identify everything already. Second step, what you need to do is draw a straight line intersecting the center of the lens. Okay, next, draw a parallel line that is in line with the principal axis and denote and continue it with the first focal point. And you realize that this is where there is the intersection. You draw a straight line with an arrow to indicate this is the image. Do take note that you are also required to label all the direction of the arrow. Okay, and therefore this is the answer. Now, there are 6 different scenarios that you need to remember where u, or the distance of the object from the lens, u, is infinite, and usually you can't even see the arrow here. What you will be displayed is the object height. Okay, and what this does is the characteristics of the image is inverted, real, diminished, and the application is a telescope. Now, how to know the characteristics of inverted? Inverted is where if the object is moving at the top, the image should be on the opposite direction. So this represents inverted. If it's of the same upright, you would see that it tends to have the same direction as the item. Okay. Over here actually is further behind, but generally that's the idea of upright. Next is virtual. Virtual mainly means that the image is on the same side as the object. Whereas if you see for real, on the other hand, the image and the object are of 2 different sides separated by your lens. Okay, so that's real. Diminish means becomes smaller. Okay, so that's what they meant by, and it's usually determined by the height. Enlarge means becomes bigger. As you can see, this height of the image is bigger than the object. This height of the object is bigger than the image. Okay, so these are some of the things to take note of, the characteristics of a image. Then of course you will also need to know how to go about drawing the different lengths. So always remember the steps that were shared just now. Then you draw. So if the object is more than 2f, that means 2 focal distance, then you will realize that the image formed is actually in between of f and 2f. But you don't have to really remember this, because by drawing the steps you can determine it. Okay, for 2f exactly, it will be the same. If it's in between of f and 2f, okay, over here, then your image will actually be very far away, and of course this actually gives it like a projection, or it can be used as a projector. Spotlight, where your object is of the same distance with the focal length. Okay, and of course vice versa. So this one, very important, you have to remember it during examination. Okay, and most of the question requires you to go about drawing, if not explaining what are the characteristics, and followed by the applications of it. Okay, so we have come to the end of this segment of light. And so to recap, we have talked about reflection, we have talked about refraction, and finally we come in to talk about the converging and diverging lens. So these are the 3 main aspects that you need to study for light.